Hi, I'm Alan Bresnick, Cable Video Practice Leader for Light Reading. I'm here in Denver at the SCTE Cable Tech Expo show. We're going to be talking about the future of CCAP and distributed access architecture with the top technologists from ARRIS. Specifically, I'm going to be speaking to Tom Cloonan, who's CTO of Network Solutions for ARRIS. Hi, Tom.
Hello.
How are remote PHY architectures, remote CCAP architectures, and integrated CCAP architectures different from one another?
That's a great question, and it's an interesting question with, I think, an interesting answer. Those three architectures, one of them is the current architecture. It's the integrated CCAP that we all know and love, and it's used out there in the real world today. Two of those are futuristic architectures, the remote PHY and remote CCAP. Those architectures, I typically put those underneath the umbrella of new technologies known as distributed access architectures, otherwise sometimes known as remote gadgets. And those are based on a new approach to providing the CCAP functionality that splits or chops up the functionality of a CCAP box and moves piece parts of that functionality out of the head end and out into the fiber node. And before you can go into any details on it, we have to just mention what piece parts we might be chopping up. And there's really two piece parts inside of every CCAP. One piece part is the MAC, Media Access Control functionality. And that's the functionality that takes packets that are coming in and does packet level processing on them. It does things like access control lists, scheduling, forward error correction on the packets and things like that. It determines which packets are going to go through and when they go through. The second piece part or subsystem that is operated on inside of a CCAP box is the PHY, or the physical media layer. And that's the subsystem that takes those packets and chops them up into bits, and then takes those bits and actually turns them into sine waves that can be placed in the analog spectrum on the HFC plant. So two very different functions. The MAC function is oftentimes done in microprocessors and FPGAs. The PHY function is oftentimes done in FPGAs or purpose-built ASICs. So two very different functions, piece parts. And as we look at the future and talk about moving these piece parts out to the node, you can do it in many different ways. You can leave both piece parts in the head end, that's the integrated CCAP. You can pull the PHY functionality out into the fiber node, leaving the MAC functionality in the head end. That's a remote PHY. Or you can pull both the PHY and the MAC out to the fiber node, and that is remote CCAP. Both of those new architectures, the remote PHY and the remote CCAP, actually require the use of digital optics or Ethernet to transport the signals from the head end out to the fiber node. And that's a major change from what we do today, where we use amplitude modulated optics to transmit the signals from the head end to the fiber node. So really the three architectures are similar. They do the same function, but they do it with their subsystems positioned and placed in different locations. Either everything in the head end, half in the fiber node, or everything in the fiber node.
Tom, why are some MSOs interested in moving towards remote PHY and or remote CCAP architectures?
I think as we look at the future, we need to first of all state that MSOs are not just looking at remote PHY and remote CCAP. They are looking at all three of the architectures we just described, the integrated CCAP, the remote PHY, and the remote CCAP. And they're looking at all three and trying to look at the pros and cons of all three, because each one of those approaches has its own benefits and disadvantages. There's no one perfect solution. There's no one-size-fits-all solution. So some MSOs are looking to stick with integrated CCAP because they're familiar with it, they know it works, and actually they know that there's going to be benefits from Moore's Law that are pushed into the integrated CCAPs moving forward. In some preliminary studies that we've done of integrated CCAPs, we foresee that through new revisions to our circuit boards, we can probably get to about 8 times more density in our integrated CCAPs moving forward into the future. And that's going to go a long way to allowing the MSOs to continue to use integrated CCAPs, and many, if not most, likely will. But there are MSOs that are going to run into problems even with those types of improvements with integrated CCAPs. They'll run into problems in really 3 areas, I think. Area number 1, some MSOs look to doing a lot of node splits going forward. They've mentioned maybe doing 10 to 20 times as many nodes as they have today. So they'll need 10 to 20 times as many signals to be transmitted out of the head end down to all those nodes. And to do that, they're going to need a lot more elements that create those signals. If they stick with integrated CCAP, they're afraid that maybe the integrated CCAPs won't be able to keep up with that kind of increased growth out in the fiber node area. And it'll require too much power and rack space in the head end to stick with integrated CCAPs. So for those MSOs that think that might be a problem, they are looking to remote PHY and remote CCAP to get around that problem of head-end power and rack space. There's a second problem, which is optical nonlinear noise issues. It's related to the first in a certain sense. It starts out with the same problem. They know they're going to do a lot of node splits and create a lot of new nodes out there, 10 to 20 times as many nodes in some MSOs. And to get signals down to all those nodes, some are thinking of using wavelength division multiplexing to transmit multiple wavelengths or lambdas on the fiber down to all those fiber nodes. But when you start to put a lot of lambdas on a fiber and those lambdas are carrying amplitude modulated sinusoidal signals, they tend to suffer from nonlinear optical noise effects, cross-phase modulation, stimulated Brion scattering, stimulated Raman scattering, and all that noise tends to decrease the signal-to-noise ratio and make it difficult to transmit these amplitude-modulated signals down the fiber. So the problem that problem is showing up exactly when MSOs are also thinking about going to DOCSIS 3.1 and going to 4096 QAM or 16384 QAM, where they need better signal-to-noise ratio. So it's kind of a perfect storm of events with this nonlinear optical noise showing up just at the same moment they're trying to go to DOCSIS 3.1 modulation orders. So as a result, many will decide that they might want to go to remote PHY or remote CCAP, where they switch from sending amplitude modulated optical signals over the fiber, instead send digital optics, on-off key signals of Ethernet over the fiber, which are more resilient in the presence of that nonlinear optical noise. The nonlinear optical noise doesn't go away, it's still there due to all the lambdas on the fiber, but the on-off key signals of Ethernet can recover the bits out of the fiber much more easily than an amplitude modulated signal. So that's a second reason MSOs are looking to go to the remote PHY and remote CCAP. The third reason is cost. Some think that by switching to digital optics, Ethernet optics, they may get on a lower cost curve moving forward into the future. So for all those reasons, some MSOs are really looking at remote PHY and remote CCAP. The difference between remote PHY and remote CCAP, which one to pick, really boils down to whether they want to reuse equipment that's already in the head end, or maybe allow themselves to share MAC processing functions in the head end, and to do that they can probably would choose remote PHY. Other MSOs would probably move to remote CCAP if they wanted to find a more simple approach, a single box solution, if they wanted to eliminate some of the distance limits that exist between the MAC and the cable modems. By moving the MAC all the way to the fiber node, they can get rid of some of those issues. And also it tends to be the system that pulls the most power and rack space out of the head end. So MSOs that really worry about that might go to remote CCAP. So in the end, we think MSOs will be going down all three paths in the future. Most maybe will go down integrated CCAP, some will go down remote PHY, and some will go down remote CCAP path.
So given that, when might cable operators start to deploy remote PHY and or remote CCAP architectures?
There's a spec activity going on, probably going to move into cable labs in the very near future that's going to try to define some of the interfaces for remote PHY. So there's a lot of activity, a lot of things changing, a lot of things taking place. My guess is remote PHY, remote CCAP systems will likely show up in the field in the 2016 kind of time frame for early deployments, early field trials. Probably ramp up over 2017 and 2018 with both types of systems showing up in the real world. As a company, ARRIS, we are definitely aimed at building and developing products in all three of those spaces, integrated CCAP, remote PHY, and remote CCAP, and we will be phasing them in just in time as the MSOs need them. So we're excited about that coming forward into the future.
Very good, Tom. Thanks for joining us today.
Thank you.